PolyNat supports companies in their innovation process towards the eco-design of high-added value bio-based materials. PolyNat brings together 8 research centers located on Grenoble University campus. Their complementarity skills and geographical proximity enable them to develop in strong synergy research projects ranging from proof of concept to pilot scale. PolyNat's researchers use renewable resources from biomass. They extract the elementary bricks, functionalize them, and assemble them to design innovative multi-scale bio-based materials and devices such as self-healing gels to regenerate human body tissues, biosourced foams for building insulation or automotive, micro-nanoparticles to protect and guide an active substance, nano-organized films for green electronics, solar panels, OLEDs, connected and/or barrier papers, water, fat, contaminants, gases, eco-friendly bioenzymatic fuel cells. The obtained materials find applications in many industrial sectors, such as chemicals, health and cosmetics, packaging and innovative print substrates, wood building and furniture, and energy and transport. We propose collaborative projects adapted to the needs of industrialists, SMEs, VSEs, large groups, by making available the scientific skills and equipment of our research centers. The Carnot label guarantees scientific excellence and professionalism in the partnership, confidentiality, transparent and balanced intellectual property and license transfer policy, consideration of regulatory requirements and technico-economic constraints at each stage of development. Don't wait any longer. Let's create together the environmentally friendly materials of tomorrow.
Hello, everybody. So I will introduce you today a new bleaching stage. This bleaching stage is called Dalkmod stage. It was developed in collaboration with LGP2, with Nathalie Marlin and Gérard Mota, and with CTP, with Michel Petit-Conil and myself, Ophélia Burnet. So it was developed in Grenoble in France. So firstly, I will introduce you the context, the objective, and the result, and I will explain from laboratory to industry, how does it happen, and the CTP experiences and CTP new project in connection with the Dalkmod stage. The context. So today, in a lot of mills who use HCF bleaching sequences, they use chloride dioxide in acid medium. The chloride dioxide reacts on lignin, and there are no reaction on cellulose. There is no degradation of cellulose with acid, with chloride dioxide in acid medium. During the reaction of chloride dioxide in lignin, we generate some oxidized lignin, and normally another bleaching stage is used in order to solubilize and extract the lignin by the sodium hydroxide. For example, we can perform an extraction stage. During the reaction of chloride dioxide on lignin, we generate some chlorine and acidic and hypochlorite acid, and in this condition we generate chloride dioxide. So it's high efficiency, high brightness, but also we can generate some wrong species such as chlorate ion, so ineffective for the bleaching. Another species very bad for the bleaching is the molecular chlorine, because it generates some AOX, so pollution in the bleaching effluent. So this bleaching, this chloride dioxide bleaching in acid medium can generate some disadvantages, such as pollution, like AOX and COD, and the formation of chlorate ion, inefficient for the bleaching. So, there is chloride dioxide, but we can use it in alkaline medium also. But at this moment, no mill use it in alkaline medium. So the chloride dioxide can react on lignin, but the disadvantage in the past was the reaction on polysaccharide and on the degradation of the cellulose. So for this bleaching, the advantage is there is an oxidizing lignin extraction, because in the same time we have an oxidation of the lignin, but also we have an extraction on the same during this bleaching. So it's not necessary to add another bleaching stage. And the other thing we introduce, the chloride dioxide, the reaction of chloride dioxide on lignin, we generate some chlorides, and we limit the formation on hypochlorous acid. So we limit the formation on of AOX. So the advantage of this new bleaching, it's a low AOX, low chloride, and very high chloride component. But the disadvantage of chloride dioxide in alkaline medium is the depolymerization of cellulose and low efficiency and selectivity. So the objective of LGP2 and CTP was to obtain the advantage of the both process, advantage of chloride dioxide in acid medium and the advantage of chloride dioxide in alkaline medium. So the advantage, high efficiency, high brightness, low AOX, low chlorate, and high chlorate, but with no degradation of cellulose. So now I will introduce you the result that we obtain when we substitute bleaching stage by the Dalkmod stage at the end of the bleaching sequences. So the pulp, a softwood pulp, was bleached with softwood kraft pulp was bleached with OOQP stage, and the goal was to substitute the D&D at the end of these bleaching sequences by the Dalkmod stage. So the kappa number of the pulp after OOQP stages was 5.2, the brightness was 78.6, and the cellulose DPV was 812. So the goal in this test was to substitute the two last bleaching stage, D&D, by the Dalkmod stage. So this is the end of the bleaching sequences, the end of the reference bleaching sequences, so OOQP, and the end was D&D. So for D&D reference sequences, we introduce acid with chloride dioxide just before bleaching tower, after the pulp is sent to a bleaching tower, after the pulp was washed, and another D1 was performed with chloride dioxide in a bleaching tower and a washing step. So the goal was to substitute the D&D by the Dalkmod at lab scale. So in this condition, we introduce chloride dioxide in alkaline medium with addition of sodium hydroxide, and with other chemical before and after addition of chloride dioxide. So these chemicals are conventionally used in a mill, and after the pulp was sent in the bleaching tower with the same retention time as the D0 bleaching stage during the reference sequences, and after another chemical was used, and the pulp was sent to another bleaching stage, to the second bleaching tower, and was washed. But it is also possible to eliminate the second bleaching tower. And it's important to note that the last chemical used in this bleaching stage is an acid chemical. So the effluent at the end of this bleaching is acid, as for D0 stage. So it's not necessary to modify the recirculation of the effluent in the mill. For the comparison, so if we compare the final pulp after the OOQP DND or after the OOQP Dalkmod stage, we observe a reduction of chloride dioxide consumption by 38%, a reduction of retention time by 140 minutes, a reduction of temperature by 25 degrees, and we obtain similar brightness and similar DPV. So in this with this new bleaching stage, with the development of this new bleaching stage in alkaline medium, we have no degradation of cellulose. We obtain similar pulp quality, similar cellulose DPV and viscosity of the pulp than the reference pulp. For the brightness reversion, we can observe when we compare these two bleaching sequences, we obtain similar result, similar brightness reversion. We refined these two pulp. So this graph represents the drainage index versus the P5 rotation, and we can see that for the low draining index, we obtain similar tendency, and for high draining index, we obtain better refining ability for the Dalkmod stage pulp. So potentially, we can save energy during the refining. For the mechanical properties, you can see in this different graph. So we can see at the top left of this figure, the bulk versus the draining index. After there is a tensile index versus draining index, and the burst index versus draining index. We can observe that we obtain similar behavior between the Dalkmod and DND pulp. So we obtain similar pulp properties and maybe slightly better for the Dalkmod stage. For the effluent quality, we can observe that we measure the COD and the AOX in the effluent after the different bleaching sequences, and we observe that we reduce by 32% the COD when we substitute DND by the Dalkmod, and we reduce by 71% the AOX when we perform this substitution, due to a lower chloride dioxide charge applied and no formation of intermediated species such as molecular chlorine and hypochlorous acid. For the cost estimation, so we perform a little study, a little economical survey. And in this table, you can see at the top of the table the cost for the DND. So the cost when we eliminate the price of COD treatment and AOX treatment. So the cost for the last two bleaching for DND was between 17 to 21 euro per ton of pulp. And for the DALK, it was between 15 to 20 euro per ton. So we have a minimum saving to 0.8 to 2.8 euro per ton of pulp. So for example, we have a 1.2 to 4.2 million euro per year for the production of bleaching pulp of 1.5 million per ton. And in this ecological survey, we did not include the possibility to eliminate a bleaching tower and a washing step, and to reduce the energy consumption and to increase the productivity of the production of pulp. So now I will introduce you some results of the Dalkmod stage when we use it during the beginning of the bleaching sequences. So in this condition, the goal was to substitute OD-AOPD sequences by the OD-Dalkmod P sequences on softwood kraft pulp. So for the top, the sequence at the top, so we can see it's a sequence with a chloride dioxide in acid medium, following by extraction stage with oxygen and peroxide, and last D stage. And in this condition, the DAOP was substituted by the Dalkmod. So in this condition, we introduce chloride dioxide in alkaline medium with addition of conventional chemical used in a mill before and after the addition of chloride dioxide. The retention time of the bleaching bleaching was similar to the D0 bleaching stage in the reference sequences, and after this retention time, we introduce an acid in order to finish the reaction, and this addition was very quick. And after we wash the pulp, and after we perform a P stage, a conventional P stage. So you can see that the effluent after the Dalkmod was acid. So it's possible to not disturb the recirculation of the effluent in the mill, because it's not necessary to modify the heat. And yes, we obtain acid effluent after the Dalkmod stage. So it's important to note that. And it's possible also to keep all the bleaching sequences of the bleaching tower, or all the washing step. It's like you want. It's possible to eliminate the bleaching tower and the washing step, or it's possible to keep all the equipment in the mill. So for this tests, for these experiments, we decided to eliminate the bleaching tower and the washing step, but it's possible to keep it. In this condition, the result obtained on the final pulp. So we obtain, if we compare reference pulp and the pulp produced with this new bleaching stage, we observe a similar pulp quality in terms of pulp brightness, cellulose DPV, so this cellulose viscosity of cellulose, mechanical properties, the brightness reversion. We observe also a reduction of TOCL by 10. And in this condition, we decided to eliminate the bleaching tower and the washing step, and we reduce by 25 to 40% the consumption of chloride dioxide. We also improve the effluent quality, because we reduce the COD by 20 to 30% and the AOX by 70%. And for all the bleaching sequences. So the economical gain was up to €5 per ton of pulp. And in this economical gain, we did not include also the possibility to eliminate the bleaching tower and the washing step, and to save some energy. So innovation for industrial, from a laboratory to industry. How does it happen? So if you are interested. So we propose at CTP to perform step 1. It's a process optimization at laboratory scale. After, there is steps 2, a pilot scale validation, and after it's possible to industrial industrial implementation. So for the step 1, we propose the feasibility test. So the objective is at lab scale. It's to reproduce your bleaching sequence, and after to test to substitute the bleaching stage of your bleaching sequences by the Dalkmod, and to compare in terms of effluent quality, in terms of cost saving. And the objective is to see the feasibility. After, if you want to continue, it's possible to optimize and continue to improve the gain and to improve the reduction of AOX and for a similar pulp quality. After the step 2, it's pilot scale validation. So at CTP, we have a very nice pilot scale. So it's possible to introduce 100 kilo of pulp in this pilot, and it's possible to simulate a lot of all the kind of bleaching stage. So all the different sequence. So the objective in this part is to reproduce your reference sequences and after to reproduce the new sequences with the Dalkmod stage and determine and analyze the effluent quality, the cost saving, and the quality of the pulp. After, if you want to implement this new bleaching in your mill, it will be a pleasure to help you to do this. And it will be a very limited investment because as I explained previously, is just addition of pump. And if you want, it's not necessary to modify the tower to eliminate the tower effluent or washing tape. It's possible to keep all your mill like today and just add some pump, new pump in your mill. So it's very limited investment. CTP experiences. So at CTP, we perform laboratory tests on different raw material, on different pulp, craft pulp, eucalyptus, softwood, hardwood, craft pulp at different kappa number, 26 to 1 of kappa number. At the beginning and at the end of bleaching sequences, this stage was used. And this is, for example, a test performed at CTP on different sequences. So the two first line represent the test that I explained previously. But for example, for the line 3, it was a test performed on hardwood craft pulp at kappa number 5, and the goal was to substitute DND by the Dalkmod stage, and the objective was to reduce the AOX. So the X was reduced by 60 to 65% on all the bleaching online, and the chloride oxide was reduced by 50% for similar pulp quality. And in this condition, we eliminate one washing step. We performed some tests on the eucalyptus craft pulp at kappa number 3, and the objective was to substitute the DP after OODP sequences by the DALK. And in this condition, we reduce the cost by 23%, we reduce the AOX, the COD, and CO2 by 47%. And we obtained similar pulp quality, and it was possible also to eliminate a washing step and a tower. We perform also a test on softwood craft pulp at kappa number 24. The goal was to situate the DLP at the beginning of the sequences by the Dalkmod. And in this condition, we reduced by 40% the AOX, and we observe an increase of the brightness by 10% after the first EP stage. Another trial was performed on hardwood craft pulp at kappa number 0.5, and in this condition, it was the goal was to substitute the last D by the Dalkmod P after a bleaching sequences CDPO. And we observe a reduction of AOX by 22%, a reduction of chloride oxide by 65%, and a reduction of cost production by $0.43 million per year for similar quality. So the perspective at CTP. So CTP decided to build a new project connected with the Dalkmod stage. So the goal of this project is to use the Dalkmod at the end of the bleaching sequences and to substitute one bleaching stage of reference sequences by the Dalkmod to produce market pulp according to the pattern that we develop with LGP2 on this new bleaching stage. And the goal of this project is to produce also two pulp, a dissolving pulp, and a pulp to facilitate the production of MFC. So in the same line, we will produce, the objective is to produce 3 products. So this is the part of this project. So the task 1 will be dedicated to the feasibility study of the production of dissolving pulp and the pulp facility, the production of MFC. The task 2 will be an optimization of the production of dissolving pulp. The task 3 will be an optimization of the production of pulp, facilitate the production of MFC. And the task 4 will be a validation at semi-industrial scale. So the goal is to reproduce the reference market pulp with the Dalkmod stage, and pulp and dissolving pulp and pulp facility the production of MFC. So thank you for your attention. If you have some questions, it's possible to ask the question in the discussion, in a QR discussion. So you can write your question in this QR and I will answer it.